So far in this unit, we have subdivided the solution into solute, solvent, and solution, and we looked very heavily into strong, weak, and non-electrolytes. We have worked to identify the strong, identify the weak, and identify the non-electrolyte. Not only were we able to identify them, but we can predict a particular compound could fall under one of these strong, weak, or non-electrolytes. Now, these are all identification of a solution. Has nothing to do with a value, how much of that solution, how little of that solution. The next unit or next section that I will be covering will be based on not just identifying, but quantifying. And my main focus for this particular video will be concentration of solution with molarity. If you look at these image on the right, you see 3 different glass filled with water and a red dye. Which one is the most concentrated one? You will probably say the one on the very right is the very concentrated one, and the least concentrated is the one in the left. Now, concentration, you can tell by the color, but many times in chemistry, you can't just determine by color. In fact, we have to let somebody know or let yourself know through calculation, through a particular value. So molarity comes into play. Molarity is a commonly used valued expression, so it has some kind of number associated with it for concentration. By definition, molarity is equal to moles of solute divided by a liter of solution. So molarity is really equal to moles over liter. In short, I can write this as moles over liter as follows. Molarity is same as moles over liter. And it's the moles of the solute divided by the liters of the solution. We're going to dive straight into some examples by utilizing the learning check. Here it says calculate the concentration in molarity of a solution. So it's asking for molarity, so moles over liter, in which 184.6 grams of potassium dichromate is dissolved in enough water to make 0.5000 liter of solution. So this right here, this potassium dichromate is being dissolved. That's the solute that is dissolved in water. So to further illustrate, I have potassium dichromate, and this is 184.6 grams. And that's being submerged into water. And when it got submerged, this whole volume of the solution is 0.5000 liter. But we know that the molarity concentration is moles of the solute over the liter. And we don't have any moles yet, but we could definitely find the moles. So I have 184.6 grams of potassium dichromate. How do I get that into moles? We're going to multiply by its molar mass. So 1 mole of potassium dichromate and then let's go ahead and find the molar mass of that. And so I need to calculate this out. So potassium is 39.10 grams, and there's per mole, and there's 2 of them. For chromate, there's 2 of the chromate, and chromate is 52 grams per mole. And we have our oxygen, which is 16.00 grams per mole. All right, so let's go ahead and add all of these guys up and then find out the molar mass. So go ahead and you try it and see if you could come up with a value. I got 294.2 grams of potassium dichromate. Now, having this, we can definitely cancel out the grams here, and we'll be left with moles. So we'll go ahead and calculate this out, and let's calculate this together actually. We have 184.6 times the 1, which will be the same thing, and then divided by the 294.2, and then my mole is 0.6275. 0.6275 moles. Okay. But we're not done yet because it's not asking for moles, it's asking for molarity. And so molarity is equal to the moles over a liter. So therefore we put 0.6275 moles all over the 0.5000, okay, liters. And that's coming from this solution here. So let's go ahead and divide that. So divide that by 0.5000 and you get 1.255. That's in moles per liter. You could leave it like that, or 1.255 molarity. Either one works, okay? And note, I put it in 4 sig figs to make sure it falls under the same sig fig as the moles and the liter of the solution. Now here is a very similar example. You try it and come and check the key. And here is the key. Next question says, typical blood serum is about 0.14 molarity of sodium chloride. What is the volume of that contained 0.000122 grams of sodium chloride? So here it's actually giving you the concentration. It's asking for volume. It contains some grams of sodium chloride. So what do? We know that from the equation, from the molarity equation, we have some information. So molarity is equal to moles over some kind of liter. We definitely have the molarity here. We're looking for that liter in volume, but we don't have that moles. We could definitely find out the moles from getting a molar mass from calculating with the molar mass of sodium chloride. We have the mass, not the moles, but we can definitely utilize the molar mass to get the moles. So let's go ahead and do that. 0.000122 grams of sodium chloride. And then you're going to multiply by the molar mass. So come back, find out the molar mass, and check this video. So that's the molar mass. And we can multiply this by 1 and then divide it by the 58. So let's do that. We have 0.000122 multiplied by 1. Okay, that's the 1 mole. And then divided by the 58.44. And you get 2.09 times 10 to the negative 6. and this is in moles. Since grams, these guys canceled. We have our molarity, we have our moles, but we don't have liters, and that's okay because that's what we're looking for. But let's make a liter by itself. We're going to make this volume by itself by multiplying by liter both sides. And that will cancel out the liters. Okay, so that forms into, I'm going to write on the right, liter times molarity is equal to moles. Well, I want to get rid of the molarity, so that liters by itself. So I'm going to divide this by both sides. And so I could cancel out the molarity. And so now we can write that liter is equal to moles over the molarity. So let's plug that in. 2.09 times 10 to the negative 6 moles divided by the molarity, which is 0.14 molarity. And I would get as follows. Let's get the calculator out again. So that would be divided by 0.14. And I get 1.49 times 10 to the negative 5. And liters. And that is my final answer, and that's how much volume